Imagine you're building an app, and every time something changes, dozens of components need to be updated instantly. How do you do it without turning your code into a tangled mess? The answer is the observer design pattern, and today I will show you exactly how it works in Java. So what is the observer pattern? In simple terms, one object called the subject keeps track of the others, the observer, and automatically notifies them whenever something changes. It's everywhere: stock apps, chat apps, multiplayer games, even weather apps. Instead of having everything talk to each other, the subject says, "Hey, I changed," and all of the observers get updated automatically. Now let's explore the benefits and drawbacks of observer pattern. Benefit number one, decoupling. Components do not need to know about each other. This keeps your code clean and modular. Drawback. Too many observers can slow down your app. One Dashboard project I read about had a noticeable lag until the developers implemented a proper unsubscription logic. For example, a stock app doesn't need to know which UI element displayed the prices. The subject just sends updates to the register observers. Benefit 2. Flexibility and extensibility. You can add and remove observers anytime without touching the core logic. Drawback. Debugging can get tricky. Too many observers firing in an unexpected order can make tracing updates a headache. Think of a chat app. New notification systems can join in without breaking anything. Benefit 3. Real-time updates. Every observer gets notified instantly. Drawback. If observers modify the subject, you can get cascading updates or even infinite loops. One project crashed repeatedly until safeguards were implemented. Example, multiplayer games. When one player's health drops, all clients are updated immediately. Let's bring this pattern to life with Java step by step. First, let's create the observer interface. This defines a contract that all observers will implement, a function called update. Whatever the subject sends, the observer will handle it. Step 2, let's create the subject interface. The subject interface can manage observers without knowing their internal logic. Perfect decoupling. Concrete subject is a subject in the observer pattern. It stores a list of observers, and whenever a new set news changes the news, it notifies all the registered observer by calling update news method. Concrete Observer 1 and Concrete Observer 2 are concrete observers. They both implement the observer interface and define their own implementation of the update method. When a concrete subject publishes new information, these observers automatically receive and display it. As soon as set news is called, all of the observers get notified. Add, remove, or change the observers anytime your system stays clean, modular, and reactive. To recap, observer pattern offers decoupling, a cleaner code but watch for performance, and flexibility. It's easy to add and remove observers, but debugging can be tricky. Additionally, it offers real-time updates, which gives you instant feedback, but watch out for infinite loops. The observer pattern is simple, powerful, and essential for reactive systems. Now it's your turn. Which design pattern should we code next in Java? Drop it in the comments below. I read every suggestion, and your idea could inspire the next video.